Development trends of CNC machine tools. In 1948, the United States proposed the concept of CNC machine tools while developing processing machines, and in 1952, developed the first three-coordinate CNC milling machine. By the end of 1954, the United States had produced the first industrial CNC machine tool. At that time, the control system of CNC machine tools used vacuum tubes, which were large in size and had high power consumption. They were only used in some military departments to process complex shaped parts that were difficult to machine with ordinary machine tools. This was the first generation of CNC systems. In 1959, transistors appeared, and electronic computers began using transistor components and printed circuit boards, advancing CNC systems into the second generation. In the 1960s, integrated circuits emerged, and CNC systems evolved into the third generation. With the development of computer technology, many computers were applied to CNC machine tools, and the resulting CNC systems, known as computer numerical control CNC systems, entered the fourth generation. In the early 1970s, microprocessors emerged, and CNC systems centered on microprocessors became known as fifth-generation CNC systems. Since then, the era of rapid development of CNC machine tools began. In the late 1980s, the focus shifted towards improving overall efficiency, with humans as the central focus, supported by computer technology. This led to the comprehensive application of advanced technologies in information, materials, energy, and environment, as well as modern system management techniques, aimed at researching and transforming traditional manufacturing processes to cover the entire product life cycle. This is collectively known as advanced manufacturing technology. China's CNC machine tools have developed from scratch and have now become the world's largest consumer and producer of machine tools. China began developing CNC machine tools in 1958, starting with the use of vacuum tubes. In the 1960s, some prototypes were developed, and in 1965, work began on transistor-based CNC systems, and in 1968, Beijing No. 1 Machine Tool Factory developed the first CNC milling machine. By the early 1970s, CNC wire cutting machines, CNC lathes, CNC boring machines, CNC grinding machines, and machining centers were also developed. During this period, the stability and reliability of domestically produced CNC systems were not well resolved, which limited the development of domestic CNC machine tools. In the early 1980s, with the implementation of the reform and opening up policy, China introduced technology from abroad and began mass production of microprocessor-based CNC systems, spurring a new wave of development in China's CNC machine tools. China developed machining centers, CNC lathes, CNC milling machines, CNC drilling and boring machines, CNC grinding machines, and more. In the late 1980s, China also explored the implementation of computer-integrated manufacturing systems, CIMS, within a certain scope and gained some valuable experience and benefits. In the 1990s, China strengthened the development of CNC systems with independent intellectual property rights and achieved certain successes. The figure shows the world's first CNC milling machine and China's first CNC milling machine in 2009. China introduced the plan for adjustment and revitalization of the equipment manufacturing industry. launching the high-end CNC machine tools and basic manufacturing equipment, major technological project, hereinafter referred to as the All-4 project, which focuses on supporting the demand for high-end CNC machine tools and basic manufacturing equipment in the aerospace, automotive, shipbuilding, and power generation sectors. This project received key support. The All-4 project has played an important role in advancing the technology and industrial development of high-end CNC machine tools, accelerating the pace of research and development in high-end CNC machine tools, CNC systems, and functional components. It has facilitated the integration of machine tool enterprises with user companies in the aerospace, automotive, shipbuilding, and power generation fields. A batch of high-end CNC machine tools, such as Milton compound machining centers, large gantry type 5-axis linkage machining centers, and multi-spindle milling mini machines, have been developed from scratch and successfully applied to actual production in key areas and major projects. Jinan No. 2 Machine Tool Group has exported 9 large, fast, high-efficiency, fully automated stamping production lines to Ford Motor Company, USA, further expanding to Nissan Motor Company, Japan, and the Peugeot Citroën Group, France, thus entering the international market. The 5-axis CNC machine tool accuracy test, its test piece standard, has been included in the ISO standards, marking China's breakthrough in the international high-end CNC machine tool technical standards field. With the rapid development of computer, microelectronics, information, automatic control, precision testing, and mechanical manufacturing technologies, CNC machining technology has also made significant progress. The current development trends of CNC machine tools mainly include high speed, high precision, and multifunctionality. The following will provide an overview of these key aspects. Due to improvements in CNC devices and servo system functions, spindle speed and feed rate have significantly increased, reducing cutting time and non-cutting time. The spindle speed of machining centers has now reached 8,000 to 12,000 R every minute, with the highest exceeding 100,000 R every minute. High-speed cutting refers to the cutting motion speed of the tool's cutting edge relative to the part surface, which exceeds the speed of conventional cutting by 5 to 10 times, as reflected in the spindle speed, feed rate, and calculation speed of CNC machine tools. The precision of CNC machine tools is mainly reflected in positioning accuracy and repeatability. CNC machine tools are equipped with new, high-speed, multifunctional CNC systems with resolutions reaching 0.1 micron, and some even reaching 0.01 micron. This allows for high-precision machining, and ultra-precision machining accuracy has begun to enter the nanometer level, 0.001 micron. The trend is moving from the combination of different cutting processes, such as Milton, mill grind, to the combination of different forming methods, such as additive manufacturing, subtractive manufacturing, and hybrid manufacturing. Workpieces can undergo multiple process combinations in a single clamping, greatly enhancing production efficiency and machining accuracy. Machine tools have gradually evolved into systematized products, where a single computer can control the operations of an Intel production line. With the penetration and development of artificial intelligence in the field of computers, CNC systems have introduced adaptive control, fuzzy systems, and neural network control mechanisms, offering functions such as automatic programming, feed-forward control, fuzzy control, linear control, adaptive control, automatic generation of process parameters, three-dimension tool compensation, and dynamic compensation of motion parameters. The systems also feature a highly user-friendly human-machine interface and include expert systems for fault diagnosis, making self-diagnosis and fault monitoring functions more comprehensive. Currently, a new type of CNC machine tool structure has emerged on the market, different from traditional CNC machine tools. For example, a new type of CNC machine tool based on the principle of parallel mechanisms and combined with modern robotics and machine tool technologies is known as a parallel machine tool or virtual axis machine tool. This machine tool has no gate rails or sliding tables. It uses extendable servo axes for parallel support and connects the upper platform with the spindle head and the lower platform with the workpiece. With increasingly stringent environmental and resource constraints, green manufacturing is becoming increasingly important. In recent years, machine tools featuring eco-friendly designs, lightweight structures, energy-saving and environmentally friendly manufacturing, optimized energy efficiency management, clean cutting technologies, and green services throughout the product lifecycle have continuously emerged and are in ongoing development. These are the development trends of CNC machine tools.